In this video, we show the practices that support ongoing changes in student thinking. This video continues from a previous lesson in which Anna has taken up the idea of heat with her students, then engaged them in an investigation in which they tested how heat moves through matter. Midway through the lesson we show here, Anna is not convinced that her students understand how heat behaves at the molecular level. She introduces a sense-making activity that she refers to as science theater.
I was really impressed by your class yesterday. You had a little bit of trouble paying attention when we were back there, but part of that was my fault because I didn't clearly state what my expectations were before we went back there. So I want you to just give yourselves a little round of applause for all the science things you did yesterday. And that's good. All right.
Should we thank Alano for his...
You should thank Alano. Let's thank Alano. Let's also, yes. Ladies and gentlemen, to start exactly what Henry was talking about, Henry used our summary table. He got some information. Maybe he didn't remember it specifically, but he knew it was important. So we're going to start our summary table for the activity we've spent the past few days on.
Anna now engages her students in creating a public representation of their thinking. This is called a summary table. We show here the fully completed summary table for this unit, but today students will be filling out just the first row. You can see on the upper left that they will refer to this as the toothpicks and wax experiment. Each row has 4 different cells to fill in. You can see Anna's titles across the top. These include model. How can you show what you learned in a drawing or diagram? Observation. What did you see or learn in this activity? Inference. How can you explain what you saw today? What made it happen? And connection. How does this help us answer our big question? Most teachers we have worked with fill in each row in a whole class conversation with their students negotiating what goes in each cell. Anna, however, has innovated here. She has groups of students write on cards, green, pink, yellow, or purple, depending on what they want to contribute to in the summary table. For example, all the students choosing to fill in the first cell will have their cards stacked up there on the summary table for their peers to see.
So if you choose to do a green paper, green is making a model, so you're drawing and labeling a picture of the toothpick and candle activity, and you need to draw zoom-ins of the metal, okay? So you want to draw a zoom-in of the metal as it's heated and a zoom-in of the metal on the opposite end from the flame. If you choose pink, you are writing down your observation that you had during that activity. So what did you see happen to the toothpicks when we heated the metal? Just straight up what you saw, no explanation yet. If you choose yellow, now you're explaining, okay? So you're explaining why the toothpick closest to the candle fell first. You have to use the word molecules in this answer, and this ongoing list of words that all my classes have been making, okay? Heat is transferred just like dominoes. We've got 5th period saying it's like zombie tag. I want you to use those ideas to explain why that first toothpick fell. And then last is purple, making that connection back to our Coke and 7-Up lab. So if our heat source is the flame heating the metal, we can compare that to the hot plate heating the flask and the frozen soda. Okay, we have a lot of people that are afraid of filling out the yellow and the purple ones, so I am offering you, if you fill out a yellow and a purple one and you do a good job, I'm going to give you a little bit of extra credit. Okay? Because I want people to try this, especially the purple. People are really, really nervous about filling this out. Just give it a try, okay? To choose with your partner what color you would like to fill out today and get your materials, both the paper and the markers.
The water part.
Yeah, it was water.
Is 7-Up?
No, that's 7-Up.
You mean the flask in the cold bucket. Oh, yeah, that.
The water in the flask.
That's Yeah, this way.
To go and get a car from the baggie behind Mr. Stroop and maybe write a question about what verb actually is. That's a really good question, but it's not quite related to what we're doing right now. So if you write it on the parking lot, then that means we'll save it for a little later when it's appropriate, and we won't forget the question. Okay? Because that's a really good question.
Molecules are moving more and more and spreading out as it got hotter. Alright? How do you know that?
What?
How do you know that?
Heat is bouncing onto the molecule. The heat is mostly bouncing into the molecule, and the molecules like bouncing to they're bouncing into each other so they can move faster, having a large space.
Okay.
Like spraying all around.
Did you write? I don't see on your paper that you talked about the molecules bouncing into each other. So add it in. That's a good idea. That's an important idea to add in. But I have a question for you both. What if there aren't any molecules close by you? Like if you're a molecule, what if there aren't any molecules close by you?
Then it would still move around,
Yeah?
and it'll probably come to a point where there's other molecules and start to
Have you guys had a conversation about the question? Yeah? So, Cameron, did you offer some ideas? No?
I have a question.
Did you understand the question? Okay, so you can look back up at the purple one, because you have a purple paper, that's how you connect to the question, and read it one more time, and see if you have any ideas to offer, because it looks like Curtis is starting to write, but I want both of your ideas on this paper. Okay? So reread the question.
This exchange between Anna and two boys demonstrates how a skillful teacher recognizes partial understandings that learners have. Anna asks a series of questions to get these boys to recognize that they are using two different theories to explain the movement of heat.
Okay, so you just told me a lot of information. I want you to go back to the beginning and think about the very first thing you said. You said the molecules from the hot plate would go up into the flask. So are the molecules from the hot plate actually leaving the hot plate and going into the flask? No? Okay, so then what do you mean by that?
How would solid freeze if it wasn't? The molecules would have to go from the hot plate into the flask.
So then you're suggesting that the molecules from the hot plate are going through the glass and actually touching the Coke? Hey Raul, come here for 1 second. So I want you to turn and tell Raul your idea.
The molecules from the hot plate like through the flask to the molecules from the
So like the molecules from the plate burned it, which it was already interacting with the flask. So it started to make that burn up, and that passes to the molecules in the soda.
they're like magnets, they could connect to each other.
Interesting. So I'm actually hearing two different ideas. Because what I hear you saying, Jose, is that if this is a flask molecule and this is a flask, this molecule is actually going up into the flask. But you're not saying that. You're saying that this does something to this, which does something to the molecules inside the flask. So you're suggesting that this molecule doesn't actually move, it just vibrates and makes this one vibrate. But you're suggesting that this one actually travels and changes location to become like a Coke molecule.
This one vibrates too much that it starts to burn and makes the molecules in the solid vibrate, and which caused the 7-Up or Coke to boil.
Okay, so now that, what you just said there sounds a lot like what Raul's idea was, and it sounds different from the first idea. Do you understand how that's different? So which one makes more sense to you? The first one or the second one? Why?
Because the heat just can't go through. It would be burning the flash, and then the molecules that take place would be vibrating and make the soda molecules vibrate until they started to boil.
So I'm going to leave you with a question because I need to go talk to some other people. I want you to think about something Jose said, that the flask is blocking or it's like a barrier. I want you to think about what the molecules in the flask are like and why they would block any other molecules from moving through them.
I have a question. You know, we did on the experiment right here, everybody standing. It's like the molecules, they're all like one because they're interacting, and they're passing the heat, so it will be like there's just one like solid.
Okay. That actually sounds like it directly relates to the question I just asked you. Don't you think?
By the end of the class, Anna's students have modeled what happened in the toothpicks and wax activity, described what they've observed, tried to explain what happened in the activity, and attempted to use the activity to explain what happened in the distillation demonstration. Over the course of this unit, ideas from 5 activities like this will be made public on the summary table. Students will continually refer to the summary table in upcoming lessons.